Hey, it's Phil here again, and welcome to the next edition of the Wells Design Guide series. In today's video, we will be discussing the design and implementation of precast connections. Connections are an important topic in the design and implementation of precast concrete. Understanding the wide variety of connections and applying this understanding is critical to ensuring the structure's integrity. In today's video, we will cover the following topics. Types of connections, important considerations in selecting connections, manufacturing and erection considerations. Precast connections come in all shapes and sizes. Choosing connections may seem daunting, so when you need guidance, it is always helpful to go to the Wells website and look at the Wells Design Handbook under the Learn tab. Precast connections can accommodate any construction type, and you will find numerous connection details for common conditions. Welded connections are the most common style of connection used in precast concrete construction. End bed plates are fabricated in the precast plant and cast into members. Erection plates are then used in the field once the product is placed to bridge the joint between members and weld them together. Tolerances must be considered in all connection types, and welded connections are no exception. Bolted connections are another option and are typically used in cases where glass or other elements near the connection can be damaged from the welding process. Bolted connections can also provide additional tolerance or be used in temporary conditions until a proper welded connection can be made. Corbel connections are integral to precast construction and primarily support gravity load. They can be cast in concrete style corbels or made from welded steel plates as well. It is important to keep in mind that there are literally hundreds of custom connections you can create with precast concrete construction. Standard connections are the most efficient and economical. It is always wise to consult with Wells pre-construction engineering teams early on in a project to determine the best connection method. The first thing to consider when designing connections is what it will be used for and the loading it will be subjected to. Understanding the overall load path of the structure will help you analyze the actual applied loads that occur on the connections. Connections can often have several loads applied to them in different directions, so understanding the various load cases is critical. Once you know the loads, selecting a standard connection that utilizes standard material first is useful if it is adequate for the load. Custom, one-off connections often result in materials with long lead times that are more expensive and less efficient. Environmental factors and exposure of connections should also be considered. Where possible, placing connections in locations that are shielded from weather or thermal effects is desirable. If the design calls for a special finish, that material must either be ordered and shipped directly to the manufacturing facility or shipped out to be finished elsewhere and sent back. An example of this is an end bed plate fabricated in the precast facility and sent out to be hot dip galvanized. Projects in highly corrosive environments like wastewater treatment plants will require special finishes. Be aware that these various finishes have associated costs. Another crucial aspect to consider is how the connection will be installed in the field. This consideration, when addressed early in the design stage, can prevent costly slowdowns later. Wells field supervisors play a key role in providing practical feedback on what is most feasible for field personnel. Their input, combined with other considerations, directly influences the safety and efficiency of the field crews. In the end, precast concrete connections are an essential part of the constructability of a precast structure. Before you start your next project, contact Wells for more information to find out if precast is the right solution for your project.